Right, advent of code, day 19, beacon scanner. Um, I was hoping for an easier one today, and it's not. It might be harder than yesterday's. We'll see. Um, so the basic idea is, let's see, where's some actual example input here. So I'm going to get a list of scanners, and each scanner is going to have a list of coordinates like this. Okay, and each scanner can see up to, I think I said 500. Spaces in any direction. Is that right? Where was it? They can only see up to five, between 500 in any direction, right? So, um, oh no, that's fine. Up to 1,000 in any direction. But it's not going to detect this one because if it's at 500x and the thing is at 1501, it's over 1,000. It's out of there. So, it's kind of a weird thing because it only matters if one axis doesn't do like a triangle, a distance, a Cartesian distance, but fine. Okay, we'll apply that constraint. And so the scanners overlap. And so you can see like, if all these points here in scanner one are relative to scanner one of the same beacons might be in scanner, or scanner zero, one of the same beacons might be in scanner one, but it's gonna have a completely different point because these are all relative to scanner one. But if I have enough, they tell me that for every scanner, there's at least one other scanner that has 12 shared points. And so back to the top here, for this example, they show two really simple scanners where one is like here, scanner one is these points. So there's 0 to 4, 1, no, that's 3, 3, and there's 4, 1. And here's the second scanner with these. Now you can see that this BBB like lines up nicely, so you can combine those to see like the two scanners are right here, even though none of the points are the same. So the goal for this is to put all of the scanners into the same space, basically get them all mapped into the same space and figure out which beacons overlap. At the end of the day, each scanner is going to give me, in this example, it looks like 20 points. But a bunch of them overlap with other scanners, and so the question is how many beacons are left. And so out of this whole list of scanners, or out of this whole list of beacons from 4 different scanners, they reduce them all down to, and eventually figure out that there are 79 beacons left. So that's the question. There's one other twist in here, if that wasn't hard enough, and that is that we can't assume a scanner knows doesn't know it's rotating or facing direction, which is to say, we know for sure that it sits on the same XYZ axes. Like we don't have to worry about like individual degrees of turn. But in the example above, we assumed that they both had the same XYs in just a 2D space. But we can't assume that here. So when I get, when I see this scanner is, if this was XYZ, this one could be YZ negative X. So, and apparently they say there's 24 different orientations that each scanner could take. So I'm going to need to take that into account. So I think the strategy here is going to be, we're going to first have to parse the input, which is actually not going to be trivial, but we'll need to read in, well, it won't be that hard. We'll read in each scanner, we'll create a list of scanners, and for each scanner we'll have all the points, the beacons it detected, and the positions in its relative to itself. Then we will loop, we'll take scanner 0, for example, just as the first one, or we'll pop one off that list. And we will then go through all the other ones, and we'll try to see the distance between each. We'll have to figure out the distance between each point and each pair of points across the two scanners. And if we get 12 that have the same distance, for each orientation, we'll have to do this. And if we get 12 that have the same distance or more, then we'll know we have found our match and that they overlay, and then we can convert. We'll take the orientation for that new scanner, we'll add it to our list of good scanners, and then we'll go through the whole list again. Now looking for another one that overlaps with one of the two that are now in the list of good. And then hopefully at the end, we'll have a list of all the scanners and we can just sort of collect the points and be done. So and that's easy enough. It's really 3 steps. 1 is read the data. 2 is figure out how to do the orientations. We'll probably just have a function that can return all the different orientations. And then 3 will be the loop to compare and solve. So with that, let's jump into Python. The first step is going to be reading the input. Let's see, day 15. So I've got as far as my kind of typical shell here where I'm going to just read all the data in. We'll do again 19 example. So we're going to, I'll notice there's a blank line between each scanner. So that's good. So we can do raw scanner data equals data dot split. Actually, let's make sure we get rid of any extra on the end there. On double new line, and that should give me all the raw scanner data. And then I can do, I think I can do this. Let's see. So we'll do for line in lines in raw scanner data dot split on new line. I think we can just do this in a list comprehension. We will line dot split on that, and then that'll give us an array of 3, and we will map tuple map int that. I think that's so for scanner data in raw. Actually, we can just do data dot split and like that. There we go. That should work. And now we need scanners equals that. Scanners dot append. Let's see if that worked. Let's see. Python 3 minus I. Day 19 example. I'm missing a G. Okay, so we need to skip the first. The first line is going to always be that. That's not what I wanted. I wanted it here. So basically I'm taking, when I do the split on new lines, I want to just throw out the 0 line every time. Scanners. Let's see, len scanners 5. Vim 19 example 1, 2, 3, 4. Okay, that's right, 5. And each one has len scanners 0. 25 beacons. They all have 25 beacons. That looks 26, 25. This is looking pretty good. 24 or 26. Let's see. So if we can do a word count minus L on that, and it's 136 lines. And if we do len S for S in scanners, 127, and we threw away 5 headers. 5 plus 4 new lines at least. So there we go, 136. So we got that. That's looking good. I'm happy with that. So scanners is that, and what I have is a list of tuples basically for each scanner. Awesome. So I mean we sort of said the problem had 3 parts. So we're gonna have to figure out read in data. Part 2 is going to be generate rotations or orientations. Then step 3 is going to be solve problem. All right, so next we need to generate all the orientations for each one. And I think this is going to be the hardest part of the problem. I've been doing some research here, and I found this page was probably the best at explaining why there's 24 different orientations that we can go by. And so I started off trying to do some loops and things in my head. At the end of the day, this right here, this page, and I'll include a link to this in the description. This, if you can't wrap your head around it, what you can do is basically say, create the list of points that we want to do. So I won't make you, I typed this out with the video paused, but we can create a function here that looks like this. So it's gonna, oops, let's undo set paste. So it looks like this. Basically, it takes a point and it returns each of the orientations here. And you can, I'll show real quick. So this one is, if this is X, if this column is X, this column is Y, and this column is Z, and we kind of go top to bottom. So X becomes X, Y becomes Y, Z becomes Z. That's easy. That's this one right here, X, Y, Z. The next one, X becomes Z, Y becomes Y, and Z becomes negative X. So Z, Y, negative X like this. And so when we go through like that, we can generate all these points. So I can give it 1 point here and get a list of all the points, all 24 points that could come out of that orientation, the different orientations. Now what I needed a way to take a list of points. So, one of our scanners, for example, and I want to get 24 lists back, and I want all of them paired together. So I think what we're going to do here is we're going to say def generate orientations, and we'll take in a scanner, and let's move this down a little bit. So what we're going to do is we're going to make, I wonder if something is off in my, I noticed I didn't get an auto pass. Oops, let's see what we broke, because I think there's an error somewhere. Oh, maybe not. It stinks I'm not getting auto tab anymore. Oh, all right. Anyway, so we'll do so P for P in scanner, right? So that's going to give me all the P's. So if I, where's my, I have scanners, so I can do scanners sub 0 and get some points. So if I do, let's just call that scanner equals. So if I do just this, P for P in scanner, I'm going to get the points again. Now, if I do orient point around that, I think I need to do orient point and put a star here. Yeah, that worked. Okay. And I covered this in a previous video, but when I put the star here, it basically says if P's got 3 items, it expands those into 3 individual items and passes them in, which is what the function needs up here. It takes in 3 items. So that's what the star does. Now that's going to give me, let's call this Y for the time being. Len of Y is still 25, the number of points. For each point, so if I do like len of, whereas before, it just had 1 point, it was 3 things. Now I have 24. And each of those 24 is 3 things. Hopefully that makes some sense. So like Y of 0, 0 is the first point. Y 0, 1 is the rotated point. So what I want to do is I want right now it's grouped by each point, all its orientations. Each point, all its orientations. I want to zip those together. So what I'm going to do is zip star like that. And now if I do len of Y, oops, we need to go ahead and do list around this, at least for demo purposes. Len of Y 24, and then like len of Y 0 is gonna be 25. So now what I've done is I've got the 24. I've got the top object is each of the orientations. So if I say Y of 0, I get back 1 of the orientations of all the points in the scanner. If I do Y of 1, I can loop over Y now. I won't call it Y in the program, and I can loop over different orientations. And so we will do that. So here, what do we? Let's grab the code we used. So delete list of. I think we can just return that actually. So that is going to take a single scanner and it's going to convert it into an array of 24, where each 24 has all the points in the scanner in a certain orientation. So that'll work well nicely. I think that's all we need to do there. So now we'll need to solve. Oh, now we just, it's like those memes where it's like, how to draw an owl, draw this eye, finish the owl. Now we just need to finish the problem. So let's go through let's talk through what we're going to do basically. We are going to take, we're going to create like known equals scanner sub. Actually, let's just do scanners dot pop. So we'll pop something off into known. I don't think there's anything special about making sure we're in the first one. And then we will. Now we're going to loop over. So for scanner in scanners, that's the remaining scanners. I'm going to need my auto indent here. I don't know why it's not working. So for scanners, for orientation, did I already use orientation? Nope. Okay. For orientation in scanner, then now I'm going to have a single orientation, and I want to compare it to. I want to get the distances basically to all the points in the known scanners. So we will do for P1 in known for P2 in orientation. I guess up here we can define distances equals like that. So now we'll do, let's see. So we're going to have these 2 points. So we'll say, we will do a zip P1 comma P2 to pair them together. For X, let's see. A comma B in, and so the answer is going to be A minus B for A comma B in there, and that'll be that. So I think distances dot append that. So we'll append that distance. If actually distances, we should make a counter, honestly. And if we get then 12, if we get anything in the counter that's above 12, so we'll do from collections import counter. We'll do counter, and we'll do distances of point plus equal 1. So basically, we're going to calculate all these distances. And so we'll say print distances. Well, I'm going to need to put a break there. Line 38. So we'll come here and we will mpdb minus c break 38 minus cc. Oh yeah, we got some errors. Append is not defined. Where did I append? Oh, I don't need the append. Just need to make that a tuple. I think that's good. Closing parentheses do not match opening parentheses. Okay. Int is not iterable. Let's break one line earlier and figure out what's going on. 37. Okay, so what do we have here? Do we have P1 is a point, P2 is an integer. Ah, okay. Let's see. P2 is an orientation. So scanner is our first orientation. Oh, I never got the orientations. So I need to do and generate orientations like that. So now P1, P2, it looks good. So let's see, what does this look like? List. Didn't like that. Let's see. List of error in argument. P1 times P2. So if I zip P1 and P2 and I list it, I should get the. I wonder why that doesn't work. Is it because I'm doing tuples and not lists? Do that. List zip P1 comma P2. That works. Let's try this without that. That works too. I don't know why it's not working in the. I don't know why it's not working in the debugger. Sometimes debuggers are weird like that in loops, but okay, we'll take that. So our zip looks good. And we're going to subtract the distances. That looks fine. Okay, so let's step. What's distances looking like? Dude, it's still calling these a generator expression. That's not what I wanted. Do I need to get rid of this? Didn't mean to close that. Oh, Tmux failures. All right, Python 3 minus M, PDB minus C, break. What line are we going to get to? Let's go to 38. 38 minus CC. 19 example. Oops, I need day 19 pi. All right, can't do that. Unhashable item list. I wonder if we should make it a string. I don't know. Let's x equals, then we should have a list there. Let's break there and figure it out. So we go back to 37. Next, what is x equal to? What do you mean it's not defined? This is getting brutal. Let's see. All right. We know we're getting our 2 points where we want it. We just need to figure out how to track the distances for this orientation. I guess we will let's put a pass here for a second. Let's just come here. We're gonna come back and build this up. 37, yeah, 37. Okay, so we have P1 comma P2. So we have 2 sets of points. Okay, we can zip those. We can do A for A comma B in. That should work fine. Okay, can also do B, yeah. We can do A minus B. Okay, so there's our distances. That looks nice. And now we just want to do distances. So I can't put a list in here. What can I do? I could do, what if I make that a string? What does that do? And then can I do distances of that? That's equals 1. All right, well, that's kind of ugly, but we'll give it a try. This. We're still gonna want to break on 38 because I'm scared to let this run the entire loop. So let's come back here. 38 distances. What do we got? Everything is a 1. So that probably means the orientation is not right. But let's check. So we can say, so let's see, how do I get the max? Distances, I did this in another video, I'm pretty sure. Distances dot most common. Oh. 1. Okay. Sub 0 sub 1 should give me the value. Okay. So if I do if distances dot most common 1 0 so 1 is greater than or equal to 12, print found it. Let's just see if we can. Okay, so it found 2 orientations, and I don't have any clue what I'm not at all tracking what I'm doing here. So this is not super. So we need some way to know what we found. Or what we're going to do here, I guess, is we're going to return. Let's see. We found 2 orientations that fit in. So what we're going to do is we're going to want to take those. We're going to want to orient those things back to the new, back to the old, back to the known, right? And add those to our list. So we will, distances is more than 12. I also want to make this a function so that it doesn't, so I can return and then come back and start it fresh. Maybe we'll do that. So what we're going to do is we're going to say print f. Let's put a breakpoint here and see what we got, because it's too. I'm having a hard time wrapping my head around it. Minus c break 38, 39. C. So what do we have here? We're gonna have distances. What do we look like? There's a 12, there's 1 point. Oh, there's 12 points that have this same distance. So when we're in this orientation and this, there's 12 points that are overlapping. That's exactly what that means. Okay, that's cool. So I think we're good. So what we want to do here is we want to say known. What does known look like? Just make sure I got it. Known is just an array of points. So we want to do known.append. We should make known a set. See if that messes it up. Known dot add orientation. So we're going to add that whole orientation because orientation is also a set of points, right? It is. So let's see if this works. We're going to still have our break at 39. So known is a set. So if we do known dot add orientation, have a poorly named variable. Known is now a set of more points. Actually, let's run that again. So if we do len of known, we do len of orientation, 25. If we then step, and now if we do len of known again, it's only 27. That's not what I expected. I'm guessing it added that whole thing as one thing and not added, yeah, look, here's a double. That's not quite right. What we need to do is add, I wonder if we need to do known.add orientation like that. Yeah, add takes one argument. So I guess we could do known.add x for x in orientation like that. So len known is now 51. So it was 26 and 25. Ooh, but I expected, oh, okay, that's what I would have expected. So first I need to adjust every point in the orientation. Do I need to adjust? No, because the orientation is already in that. Oh, but I need to subtract the distances to it. So we made sure we were lined up, but we still need to subtract off. We still need to add the distances. Okay, so we'll come up here and we'll do match equals let's see, what was distances most common? 0 like that. So 0. So we want to do equals like this. Let's just get the 1. And then we'll say if most common of 1 is greater than or equal to 12, then let's match. Match equals x, y, z for x, y, z in orientation. It's not going to be x, y, z. It's now going to be x minus most common 0. That's a terrible name. Let's just do MC because I don't want to type so much. MC sub 0 sub 0. Y minus MC sub 0 sub 1. I'm saying minus. Should be minus. Okay. We'll see. z minus mc sub 0 sub 2. And then we will known dot add for m in match known dot add I'm missing a closed parentheses here. Let's see what we got. So we're breaking on this 12. We should expect it to be okay. So we're not at that one yet. Bad breakpoint. Let's break when we get inside this. We want to break right here at 42. Uncaught error. Unsupported type int for string. What number? What line are we on? 40. Okay. Let's see what we're doing here. So we have orientation. Okay. So if we do x, y, z for x, y, z in orientation, it looks the same. If I do x minus 1, y minus 2, and z minus 3, that works fine. So what if I do, so let's look at what is MC of 0? Oh, it's a string. Shoot. I made it a string because I needed to make it a string. Offset equals MC JSON.loads. Import JSON. That'll work. MC sub 1, sub 0. So now I can go back to making this most. My variable name was only terrible because I was having to type it so much, but now that I'm only going to have to type it a couple times, let's make it good again. Offset equals most common sub 0 JSON.loads that. And now I can do, I guess I'm going to off sub 0 off sub 1 off sub 2. Try that. Let's go back and try to break on 43 now. JSON's not imported. Go to 43 where we are. And hi. Just give us a place to break after that loop on 45. So what is length of known now? 51 still. Shoot, I would have thought we would have been 12 points. We had 12 points less than that. We could try real quick because we subtracted. We could try adding this back in. See if the offsets were meant to be that way. That's a quick check. 39, 12 less. Yes, okay. So, after all of that, we have now shown that we can loop through a bunch of orientations, find the one that matches up. So we're going to need to do two things now. We're going to need to remove that scanner from scanners, and we're going to need to add that scanner to known. We're adding that scanner to known. We did a good job there. We need to make sure this scanner and all of its entire scanners gets removed from scanners. So I think we need to make this a function now to make it work well. Def find overlap, and it's going to take in a known set and a list of scanners. We will come here, and all we need to do is return. Let's not manage any of the stuff. Let's just return the scanner and the offset. Let's see, what do we need to return? I guess the scanner and the orientation. So we can get rid of all this. If most common is 12, is greater than 12, we get rid of all of that. And we return scanner orientation. So now we can come in here. Don't need that. We can say known equals set scanner. I call them scanners. Scanners. Pop. So we start by popping off one of our scanners. Then we're going to say while scanners found scanner found orient equals find overlap known scanners. We will have an orientation, so we're going to do we need that offset still. So we will need, I wish I hadn't deleted that so quickly. We'll need to update the orientation into the right frame. So we're going to need to come back here and do our off equals most common 0. That's what we'll JSON loads. So that'll give us the array. And then we will do, for this, we're going to do x, y, z for x, y, z in orientation. And we're going to do each of them by the offsets. I could probably do this with a zip, but since it's just 3, it's probably faster just to do it this way. Z minus off 2. Like that. So we return scanner, comma that. Now we're returning a normalized orientation. So now the found orientation here is good. So now we can come in here and we can say for m in found orient known.add m, and then we want to do scanners.del found scanner. Now scanners get shorter and known gets longer. Seems plausible. And when we're done, we'll have, let's see, so we can do print len known len scanner. What am I missing here? 35. Oh no, something about the white space is really screwing up in here. Oh, what a disaster. That looks good. Okay. Did it again. Python 3, day 19, 19.example. Scanners octal. How do I delete something from a list? Python delete item from list. Oh, is it just del? Let's see. I don't want clear. I don't want pop. Remove. What does that mean? Unexpected in this file. Oh. There we go. Missing a parenthesis. Well. Oh. 127 was the number of points in known. 127 beacons? That doesn't feel like the right answer I was looking for. There should only be 79. Well, for one, I can, for troubleshooting purposes, come up here and do, oops, not there. Scanner sub 0, and then do this. Scanners equals scanners 1 bang. So now we'll all be oriented closer to that. It's interesting that on the jump from, it seems off now because when I was where did I print that? Print that there. Yeah, so like it starts at 25 and then it goes to 50, 50, 75. So it's not something about the offsets is wrong. The thing I had right and then deleted and now oh, I changed these to pluses, I believe. Now, let's see, I bet you if I just do this. 79. 79, that was the answer, right? Let's run the puzzle input and we might have part 1 done. This might take a minute. There's a bunch of them, but it's not too slow. 381. Let's see if that solved it. I'd be quite happy if it does. Yes. Awesome. Let's see what part 2 has to offer. Okay, so we need to track Manhattan distance is okay, you just add the differences. Cool. And we just need to track where the scanners are. So the scanners all are at 0, 0, 0 in their original thoughts, but then so it's basically just I need to return the offset as well. I think this almost seems too easy, but let's see. Maybe we just approached it really nicely. So let's hope here. And we will also return off. And we will return offset. We can find, let's just keep a list of scanner locations equals, we'll start it off as 0, 0, 0, because that'll be fine. And so I think when we find a scanner, we have this, we have this. We will add scanner locations dot append offset. Let's check that out just to be sure. So the offsets here were, let's see, we're looking for one that's 1105. We have one that starts 1105. We do. And negative 92. I think those are the two. Is that right? Negative 92, 2083, 20, and that one was 12, 29, 23. Okay, so we got the distances right. So now we just need to, let's see. So first, let's make this look nice. Part one is len known, and now we will do for I in range scanner locations, for j in range scanner location. Do we need to do this? Do we need to do both? Yeah, we need to do both. But we don't, order doesn't matter, so we can say for if I is less than j, Manhattan distance is going to be, let's see. Scanner locations. Do I need to do, yeah, that's fine. Scanner locations sub I, comma scanner locations sub j. Get the two points. And then we need to zip them. So we will zip them, and then we can loop over them here. So this will be x comma x for x comma x in, and so we'll do x, oh not x comma x, that's terrible, x comma y, and then this will be x minus y. Is it math.avs? Like that. And then we will sum that. And let's just, to start, we'll print that and see if we get the list cannot be interpreted as an integer. Okay, we better sit here and think for a second. So let's come here and put a break at 62 minus mpdb minus cb 62 minus cc, and we run. Okay, so scanner locations. Okay, so we should probably make, I don't know, I can't imagine this is making a difference, but let's make this a list for now. So in this one, like I comma j are both 0, I'm guessing. How's I not defined? Where are we? Oh, see, I haven't done that yet. Okay. What the? Maybe I didn't save this. Why are we at 59? Oh, I guess because we just ran. Did we just print that? Or we're running into an error. List cannot be interpreted as an integer. Right. Did we not reach that point? At line 59. I in range. Yeah, of course. Sorry, this is a silly one. Really, I'm running out of energy on this. Let's see, range len. So now what do we have? I 0, j is 1. So what is that? Import math. Is it just abs? It is just abs. Okay, good to know. So sum of that equals 1357, which is not the maximum. That's okay. We didn't expect to get the maximum quite yet. Let's quit this and run it again. In fact, let's quit this and run it without PDB and see what we get. Whoa, okay. And what is the max in here? 3621. That looks right. 3621. Sweet. So now we just need to max dist equals 0. And we'll just do max dist equals max, comma, max dist. And then print string part2 max dist. Okay, part 2. I don't want to get overconfident, but I feel like we're getting close. 3621. So we gotta wait. We're waiting for the number of sets to go down. We're down to 19, 18, 17, 15, 13, 12. I mean, this is not too slow. Let's see if we get it. If we got it right here. Boom. All right, part 2 is much faster. That's awesome. So, all right, we're back up to complete here. Let's see, what do we want to talk about for this? One thing we could look at is, well, let's see, is there anything we want to do to make this faster? I suspect, like most of these things, I suspect there's a much more mathy way to do this where I don't have to force through all the orientations like that, but it's really not that slow. So let's talk about it again just to walk through what we did. Reading in the data. We're going to get the scanners. We're going to start by splitting on double lines, and then we're going to split. Interesting. What is... That's completely unnecessary. Let's see if we can get rid of that. So for raw scanner data in data split, for each block of raw scanner data, we're skipping over the first one. We're splitting it on new line, throwing away the first line because that's just like the label. And then for each line, we're going to turn it into a tuple. Okay, the next thing we need to do is figure out how we generate all the three-dimensional orientations it could be. So for each scanner, we're going to create 20. We're going to take a list of, each has like 25 or 26 points, and we're going to convert that to 24 lists of 25 or 26 points. So first I create this function that is based off of that web page I pulled up that just, give it a point and it will return the 24 options that it can be. And then I will take, so for each point in my scanner, I'm going to get the 24 points, and then I'm going to zip that. So they'll expand those out to be 24. So instead of just having a list of 24 things, I'm going to expand that out so that I've got 24 arrays, basically. And then I can zip all those together so that I get orientation 1, orientation 2, orientation 3, orientation 4, etc., all the way through the end. So I have all them grouped that way. And that'll give me this generate orientations will handle that. So now I need to solve the problem. And so I've got this find overlap function. So I'm going to pass in some known orient things. So I'm going to assume that in this case, like scanner 0 is, in the correct orientation. So I'll set that to known. And then I will take the rest of the scanners, and while that list exists, I will find an overlap between the known and the scanners. So what this is going to do is it's going to loop through each of the scanners, and for each of the scanners, it's going to loop through all 24 orientations, and it's going to create a clean, for each orientation, it's going to play this clean counter. And basically what it's going to do is it's going to loop over all the points in known and all the points in orientation, in this orientation, and it's going to create the distance. And what's going to happen if one orientation is just a shift off of the other one is that we're going to get at least 12 points that have the same distance between their 2 points in the orientation, like in all three things. And so we're going to get the most common distance here, and if that's greater than 12, so that means 12 points shared it, then we know we found an orientation match. And so then we'll make sure we'll get the offsets back out of this counter. I had to do some like kind of tricky stuff here to convert it to a string so that it would go into the counter, so I convert it back. JSON's really good at taking strings of a list and converting it back to a list to get my offset. and then I will return the scanner as well as the reoriented. So I'm going to take the orientation and I'm going to add back in the offset so that all the points in the orientation now are in the same plane as the known good stuff. And so once I get back these points, these are the actual beacons, I'm going to come down here and I'm going to first add all those points to known. So great, known now gets bigger. There's a bit of an assumption I made in here, and I'll come back to that in a second. I'm also then going to remove scanner from the scanner list because I don't need the found scanner. I'm going to remove from the list. And then just some part 2 stuff I'll come back to in a second. This print is not strictly necessary, although it's nice to sort of see progress. And then I'm going to loop again, and now I've got a shorter list of scanners. I'm going to see what overlaps with my bigger list of known. I think technically in the problem description, I should be not keeping all of the known in one list, but rather keeping individual lists of known points because there should be 12 overlap between any given 2. But I didn't end up hurting me here, and I don't see I can't even see exactly how it would hurt me. So I think technically I should be keeping, instead of keeping one set, I should be keeping up to the number of scanners in known lists of points. And then at the end, I could put all of those into a set and then let them settle out the uniqueness. But it ended up not being necessary here. So then after I do that, the length of known will have all the points. And because it's a set, by definition, if I put in the same point twice, it just doesn't care. It ignores it. Its sets are unique. So whatever the length comes out is the length. So in the example, I had 5 scanners, each had, let's say, 25, 26 points. So that's like 127. But because of all the overlaps, they're down to 79 unique points. So that's what I get out of known. For part 2, I added in a little bit where I also return this offset. Because this offset, if you think each of the scanners in its own orientation is centered at 0, well then by the offset itself is where the new scanner, the found scanner, is relative to the known frame. So when I return that offset, now I have the position of the scanner, and so I can track scanned locations. The first one is going to be 0, 0, 0, because that's what I assumed that orientation was correct, and I put it in there. And then I can add, the locations. I can start appending offsets to them. And so then down here at the end, I just loop across the whole set of scanners twice, because order doesn't matter. I can cut out half of them right there, and basically just check each one and collect a max distance, and then print the max distance. So I'll be honest, this is a problem when I first looked at it, I thought I could never solve. It just seemed really hard, but we made it through. So you're still sticking around with me. That's awesome. Thank you so much for sticking around till the end. And I will talk to you next time.